Hi everyone, it's Mike Levin, Friday, July 8th, 2016 at almost 3 o'clock, and I pushed out two videos earlier today, this last one being installing Jupyter Notebook on Windows 10, which doesn't sound like it's all about Python, but it really is. And I thought I would give another quick tutorial today on using Jupyter Notebook, that sort of indoctrination lesson. So I am going to open a command line. On Windows, this would be the equivalent of doing a CMD command to bring up the type in user interface. And I'm going to CD into home, and that puts me in a directory that I can tell what it is by typing pwd. I think it's present working directory. That's the home location on Macintosh and many Unix systems, although it's usually /home on other versions of Unix. The Mac has a few deviations from Unix conventions. But you can do a make dir, and I'm going to make dir learn Python, because what this is really is rebooting my sort of mission to help everybody break the ice and get familiar with Python. I will CD into it, and if I do an ls there, you'll see it's an empty directory. There's nothing there. I can open that directory on a Macintosh, open, and the notation for current directory, and you can see that pops up and nothing in there. These two windows will actually be quite useful on what I'm going to do as my next step. And I kind of like letting those peek through underneath the web browser. So I'm going to go like this, and I'm going to bring these two things over to that window so you can just kind of see them under the web browser, so that as I do stuff, you'll see some changes take place in these two windows. The first thing I'm going to do is run Jupyter Notebook. And again, remember, we're in this location, so when I run Jupyter Notebook, it's running from that location. And the server is actually going to start back in here. You can see the server going. And as soon as I go new, Python 3, you'll see a file gets created there called untitled. And I can change the name of that to, I did hello world already. I am going to create a new a dictionary, a special dictionary. I'll call it dict tutorial. So in a lot of my work, I have to have a certain type of dictionary, and I haven't even talked about what dictionaries are. So let me first build this up with a very typical example. So as we saw before, we can create a variable name, a range, and set that equal to the calling of a function from Python like range. And we can just put an arbitrary number in there. And now we have a range sitting here in memory that we can take a look at. Now, that's preserving it as a range object, but really it can be treated as a list simply by telling Python to convert it to a list. And there it is, 0 through 9. So that's how you can easily get a list from just a quick range, which is useful for the types of things we're doing. But what I need to do is create a Excel, a way to know what the numbers for columns in a spreadsheet like AA and BB are in a Excel-like environment like Google Spreadsheets. So I'm going to pause for a moment. And I just created a new spreadsheet in Google Spreadsheets. I haven't given it a name yet. I'll call it sample, just to make the first save occur. And you can see that the columns go from A through Z, and then it stops by convention. But if I were to insert to the right, that's AA. And if I were to, say, go like this and insert right with 6 more, it goes AB, AC, AD, AE, AF, AG, and so on down the line. And then once it gets to AZ, it'll start with BA. And these are the columns you have to sort of keep track of in your head. And previously, whenever I did this, I manually created a dictionary in Python where I would say, okay, so we see a list. We know a list is these square brackets. And on the last tutorial, I showed tuples, but what I haven't shown yet are dicts, dicts, which when you run them, there, it's a dict data type. You can take a look at that. Now that's actually a function. It's probably, it's a type, so dict is a type of object. But if we created an instance of it and invoked dictionary, you'll see the curly brackets. Curly brackets are the notation for doing dictionaries. And when I say a dict, I'm talking about something that is very similar to JSON, foo, bar, comma, spam, eggs. So Python recognizes that string format as a dict, right? So we can create an instance of a dict equal to the string representation of what we want. Now we can do stuff with it. For item in a dict, print item. And there you have your keys. These are key value pairs. So let me just hit that point home by adding a new one here. Key, colon, value. So you get the keys but not the values, and you don't get them in order. See, key is first here but it's last here. That's just because of the way dictionaries are optimized for fast lookups when you plug a key in. So if you wanted the value that went along with key, you would go a dict and then you would plug the key in and it shows you the value, name value pairs. Very familiar to anyone who's been using JSON in JavaScript in the web browser for the past few years. Python dictionaries are very similar to JavaScript JSON, just as lists are very similar to JavaScript arrays. So it's a very comfortable environment to get set up in. But say you wanted to create a dictionary kind of programmatically with a more sophisticated or automated process than hand coding it the way I did here. So I am going to just get rid of some of these boxes, go back to the beginning, and I am going to import string. And then I am going to set letters equal to string.ASCII underscore. Oh, in fact, if you wanted to see, you could do string dot and hit tab. Oh, don't make a liar out of me. It has to actually be imported for that to work. So if I were to go ahead and import it, now I could do letters equals string dot, and I hit tab, and now it's loaded in memory. Oh, there's some interesting stuff. ASCII.uppercase. Command line completion is there. So I just set letters equal to ASCII.upperspace, and let's take a look at letters. Hey, you got A through Z as uppercase. That's convenient. And now you have something that can give you a length. So I'm going to start with a simple name value pair dictionary that zips together this with, let's say, numbers equals range. Now I'm going to do from 1 to the length of letters. Now before I even do, and that would be +1. Now before I even make it take that, I'm going to show you the alternative. I'll comment that out for a second and put the tempting thing to do, which, as you know, you don't have to give a beginning parameter. You can just give something like that. And if you were to do that and print numbers, you have a range from 0 to 26. And let's show that as a list to make it a little more visual. 0 through 25, really. So I want a 1-based index. I want 1 to represent column 1, which would return an A, 2 to represent column B, and so on. So instead of that, we do this other presentation, changes it to a 1-base index, 1 to 26. Okay, so we set the stage. And now I actually want numbers to actually be equal to the converted to a list range of numbers. And we'll get rid of this one because we don't really need it around anymore. It's just confusing. And numbers. Now I'll show you the difference between printing by default, which does this sort of stacked pretty print version. If there was indentation, it would indent everything and it makes it highly readable. But when it's just a verbatim list, it actually kind of works against you. So you can do print, which gets rid of the attempt to pretty print. Didn't happen here because it's a string and they're appended together as one solid string. But even strings are sequences in Python. Dictionaries are sequences, lists are sequences, strings are sequences, tuples are sequences. All this stuff that Python works on, the core concept there is sequence. And methods that work on sequences happen to work across most of these things in general. So we're sitting on top of numbers and we're sitting on top of letters. They are the same size, they're compatible size, right? So the natural thing to do at this point is to zip. Okay, we want numbers to be what we plug in and letters to be what comes out. Now if I just do that, you'll see we get a zip object. Oh, zip object. Well, that doesn't really feel like what we want. We want to be looking at something that is the combination of this and this. Well, remember when we tried to print the range originally and we got a range object? Similar thing here. All we have to do is convert it into a dict. We have zipped together the numbers and the letters into a dictionary object. A dict equals, now it's sitting in memory and we have an index. A dict, put in any number. You know, what is the, oh, I don't know, let's say 15th letter of the alphabet. And that's O. 13. M. And so there you have it. This is a great way to make a dictionary so that if you are sitting on top of a column number, but you need to feed a alphabetic letter to an API because the API, gspread, in certain cases takes ranges as expressed in Excel format, you know, A2 through B40 to create that rectangular selection. Gspread is optimized to work on these cell ranges that are chosen as these rectangular blocks so that you can iterate through them and you know, update back all their values in sort of batched chunks. So I'm jumping ahead a little bit, But I did want to show you sort of the power of Python in how when you have a list, it's not even shown as, well, the numbers are shown as a list, but okay, you have two lists, one list, two sequences, one which is an actual list, and the other which is a string, which is still a sequence. You can use the zip function to make name value pairs and convert the resulting zip object into a dictionary object, which you can then use subsequently in your program as a lookup or mapping table. Whenever you hear the term MapReduce, that mapping step is very often using a dictionary-like object, taking some value in, a hash, and giving you some value out. One-to-one mapping, quick lookups optimized for that lookup speed, and programmatically very, very easy to produce. So this is my first introduction to Python. Once you have Jupyter Notebook installed, and as you can see, there are certain things that you just need to be told. You need to be indoctrinated into this. And then there's techniques for figuring out what type of things are available in here in an IDE. That's a useful way to do it. I could just as easily have chosen lowercase and then made the whole thing work in lowercase. I got to learn to do command line completion correctly. It's a little bit different here than in other environments I've encountered. But there you go, it's a lowercase m coming out. If I were to show the whole dictionary, you would see it as lowercase. And if you wanted a technique other than command line completion to tell you the kind of stuff you can do on an object, you can wrap it in a help. That'll show you the API for whatever object type you're dealing with. Here's the API for dictionary objects, including all these internals. Whenever you see something that has underscore, underscore, some word, and then underscore, underscore again, these are called double underscores or dunder methods. And it's very easy for an object, it's very common for an object to be loaded full of dunder methods, which you yourself are not intended to call directly. You want to look for those that don't have the double underscore, and those are the ones that you do, in fact, want to call directly. And see this items? I'll do this last demonstration here because items is particularly interesting. Tuples and dictionaries and lists tend to sort of readily flow back and forth and transform into what you need when you need them. So I have a dictionary here, as we saw when I showed it like that, but say I wanted a list of tuples. So I can step through it. I can do it with a for loop. For, let's first do keys. For a key in a dict, to show you, print a key. So there's the keys. Now if I wanted the values as well, I believe I can do, yep, see there, right? Values. And type error, okay? So the built-in function or method object is not iterable, so I am calling it as an object. You have to call it as a method and not an object. And it takes a while to get down when to use your trailing parentheses and when not to. And basically, anytime you refer to something and it gives you pointy brackets around it, that's when you know that you actually have to use the parentheses. So if I did adict.values as sort of a standalone thing in this little cell that I created, oops, you'll see the pointy bracket coming out of it. I'm going to get rid of the help. We don't really need that help anymore. It's just confusing the picture. And here, print a key. I believe if I do comma end equals quote quote, it will all put it on one line. Okay, if I wanted spaces in between them, I could do this. But at any rate, you can see when you refer to something without the parentheses, you get the representation of the object in memory. Put it in parentheses, you get the calling of the method. Okay, so we are doing for a key in dictionary values print a key, but it's actually print a value, so that would be more a val. Let's get rid of this because it's confusing. Get rid of that one, and we execute this again. Same. Oh, for a val in a dict. Oh well, it probably got messed up because of me executing everything so often. No. Oh yeah, residual in memory. If I change it to a value there, I need to change it into a value there. So I keep my mistakes intact for your benefit. Oftentimes, it's good to do kernel, restart, and run all, because that variable being used there would have thrown an error as being not declared, but because everything sort of persists in memory because of the way Jupyter Notebook works, it didn't throw an error in that case, having a different variable name here and here. So the last thing I want to show is how to get a name and a value out of this. So instead of values, it's items. So let's go for item. Now these names are somewhat arbitrary, but I'm changing them to sort of reflect what they actually are. And I will take out that end equals because I want each one on its own line. And what you have here is a sequence of tuples. Every time you ask for an item in adict.items, well, an item in adict, you will recall, now represents a name-value pair, or a key-value pair. Key, value, key, value. And they're being returned as tuples. And tuples can be unpackaged. So instead of print item, we could say print item 0 and get your names. You could say print item 1, you get your values. I could do both item 0 and item 1 in a with a comma in between, like that. Okay, but that's sort of ugly and verbose, so why can't you just unpackage your tuples up here for key val in adict.items, key val? The answer is you can. You can make it much nicer to look at. And you could even do some string formatting. A little look ahead, I can say my key is %s, stands as a placeholder for what's going to be sent back to it here after the string replacement command is put in place. And we need to put these guys in parentheses because tuples. Key is going to target that, and my val is %s. Value is going to target that. Welcome to string formatting. My key is 1 and my value is A. My key is 2 and my value is B. So this is a little bit of the demonstration of the incredible power of Python dictionaries, which are dict, lists, and tuples, and how they can be used in combination with each other to pull off some pretty amazing object shaping stuff that comes into play more often than not in making your own programs. And the better you understand the Python object model, the more comfortable you're going to be creating your own code, looking at other people's code. And I guess that pretty much does it as my first Python tutorial under Jupyter Notebook. Thanks for joining me. Hope that was enjoyable to you, and I hope to see you again soon. And of course, don't forget to subscribe.